This is section 1, graphical approach to limits, example 4. At the top of this, you can see the theorem, the limit L of a function y equals f of x as x approaches a number c exists if and only if both one-sided limits exist at c and both one-sided limits are equal. That is, the limit as x approaches c of f of x equals L if and only if, that's what IFF stands for, if the limit as x approaches c from the left is equal to the limit as x approaches c from the right, and they're the same. So that's what we've been doing with the tables. So now let's actually look at graphs. We need to find the required information for all of these graphs. So let's look at example A. We're approaching 1 according to these instructions beneath the graph. First, we want to find the limit as x approaches 1 from the left. Okay, so here's 1. Remember, it's always that x value. That's the x value we're really focused on. If we approach 1 from the left, that means we're using the left side of the graph to tell us what would happen as we get towards 1 from the left. So we're going this way, right? I'm coming from the left toward 1, and if I stop at 1, it's going to end up at the y value 1, right? Because that's where that ends up. So that means that's 1. From the right, I'm going to use the right side of the equation. Now you'll notice that doesn't end up at the same number, right? That actually ends up at the y value 2. So that ends up being 2. Now in order for the limit to exist, the left and the right have to be equal. Well, does 1 equal 2? No. Which means that the limit as x approaches 1 of this function, this graph that we see, does not exist. Now notice, I was never concerned with what the actual value was at that particular point. It didn't matter. It wasn't asking me for what f of 1 is. It was asking me for the limit as x approached 1 from the left, the right, and then the overall limit. Now it's asking me for what f of 1 is. Okay, which means I'm going to look at where the closed circle is. Where x equals 1, what y value has the closed circle? Right, because remember, if it's not open, it's, well, if it's included, that's where the domain is. That's where it exists. So that happens up here at that y value, okay, which is 2. All right, it doesn't have to be the same as one of them. It could be completely different, and you'll see that. Let's look at B. Hey, here's a really good example of that happening. All right, first, we're finding the limit as x approaches 1 from the left. So same y value. I'm sorry, same x value. That's right here. From the left, we're coming in from the left. So this is the graph coming from the left. All right, and it goes to -1. -1 is the y value. Remember, all of your answers are going to be the y values. From the right, here we go. Okay, that's at 1. Well, if one of them's -1 and one of them's +1, are they the same? No, does not exist. The overall limit does not exist. F of 1 is where it's defined. Okay, so if you notice up at +1, it's an open circle, and down at -1, it's an open circle. The closed circle is right there. And that is the point 1, 0, which means that the y value, the answer here, would be 0. Let's look at more. Let's look at example C. Okay, we're approaching 1 again. Hey, look, all the same x values. Okay, so we're worried about what's happening on this line right here. So from the left of our function, on our function, we get toward the y value 1. From the right, okay, also 1. Well, since the left limit is equal to the limit as x approaches 1 from the right, then the limit as x approaches 1 is 1. Because they're the same, you use that value. Now, is it defined there? No, it's not defined up at the top. It's defined right here. Okay, that closed circle is where the function is defined for that x value. So f of 1 is -2, because that's the y value. Another one, 0. All right, so 0 is right here, which means we're really looking up here. Okay, so we approach it from the left, and we get 1. We approach it from the right. Well, hey, look, that's going to the same thing. That's also 1, which means the overall limit as x approaches 0 is still 1. Use a different color. Now, where's it defined? Well, we've talked about this before. We talked about this every time we talk about a domain. If it's not open, then it's closed. So even though there's not an open circle anywhere on our graph, there's also not a closed circle on our graph, which means that this point is included in our graph, which means it's also 1. Okay, because it doesn't specify open or closed. Okay, a couple more. There can be vertical asymptotes. Okay, if there's a vertical asymptote, the limit does not exist. However, we are going to specify, you and I, during this class, and we're going to say, well, it's either going to infinity, positive infinity if it's going up, or negative infinity if it's going down. So depending on which one it is, that's what we're going to write. However, you do need to know that the limit still does not exist. Okay, because it's going to infinity, it does not exist. They can go to the same infinity, and we're going to write that if they go to the same infinity, that the limit is infinity. However, the answer is still does not exist. And don't worry, when you take your test, when you take your AP test, it's never going to give you both options. You will never see infinity and does not exist as an answer. You will see one or the other. In fact, most of the time you'll see does not exist. Okay, so you don't have to worry about it too much, but I do want to get into the habit of writing that. So this time, in example E, we're approaching 2 from the left. So here's 2. And we're approaching from the left, which goes down forever, which means it's negative infinity because negative infinity is going down. From the other side, from the right, this is the right side. So we go, hey, look, that's going up forever. So that'll be positive infinity. Well, are they the same? Nope. Positive infinity is not the same as negative infinity, which means that the overall limit does not exist. And is there a point anywhere on it? Closed circle. Nope. So that also. It does not exist, or you can put undefined. Right, because it's an asymptote, that means that the denominator would equal 0, which is where it's undefined, just like in our tables. So let's do F. We're approaching negative 2 from the left. So negative 2 is here. So from the left, it would be going down. So that's negative infinity. From the right, also going down. So that's negative infinity. Negative infinity is the same as negative infinity. So for convenience sake, we're going to say that it's negative infinity. However, again, for all of those answers, the answer is does not exist. And then is it defined? Well, look, there's a point there, which means that the y value is the answer to where it's defined. F of negative 2 is 0. Oh, too far. That's it.